The next unit up section is the Pine Island Shale. The Pine Island Shale was deposited on the middle to outer ramp following a deepening after the carbonate factory of the Sligo Formation shut down. It captures the maximum flooding surface of a composite sequence defined by Phelps. It's right here, and here's the change from transgression to regression, the flooding surface in here. The Pine Island Shale contains the pre-OAE1-1A right here. It starts right near. And the upper Pine Island contains the OAE1A interval proper, or part of it, and that's right up here. The Pine Island is here on the wireline log. It's showed by a big decrease in resistivity and negative SP. Very good correlation marker, lily all through Texas. The Pine Island Shale was deposited in a deeper water, middle to outer ramp setting. There is no down dip barrier reef at this time. Sedimentation appears to have been by gravity flows and mud plumes and reworking by bottom currents. Siliciclastic input was high. You can see here there's a lot of argillaceous clay material, and the yellow here is the sandy quartz silt component. Very siliciclastic rich through this section, showing the carbonate factory. A lot of it is shut down. The macrobiota became limited to oysters, mollusks, and echinoids. Things such as the benthic forams and the green algae totally disappeared. And again, a lot of this fauna here looks like it has been transported from up dip areas. Near the top are accumulations of oysters that appear to have been affected by storms, and the shells are abraded. They'd be these units up through here. Overall, in this section, it was difficult to recognize cycles, so none were picked. Now for some core slabs. The lower left is a core slab showing a scoured vent bed of a silt in a matrix of siliciclastic mud. This is the matrix of the mud. Here is a silt bed deposited by a turbidite type deposit or bottom current, but being injected as being a lone silt in this interval, it's probably coming down by some type of gravity flow, but you can see later it's scoured by currents. The next core slab, right here, shows a siliciclastic mudstone with class of silt stringers. These are little class of silt here and here. It looks like this could have been a silt bed that got ripped up again and redeposited. As I said, it looks like gravity flow deposits of some sort were common in this section. On the right is an example of clay-rich mudstone devoid of larger biota. Carbonate factory pretty much looks like it's shut down through here. There's these little sixes or shell symbols show very low and biotas. Each of these cores lack much biota, as I just said. This core slab on the left is an oyster-rich rudstone storm deposit. And I think it's a storm deposit because one, the oysters are broken or fragmented. And then a lot of the oysters have these mud layer, or these mud clumps associated with them, like here and then through here. You can see there's a mud inside of the oyster here. So I don't think this is just the oyster, certainly not the oysters growing in place. I think they're mud class, and this is some sort of debrite. On the right is a calcareous to clay-rich mudstone. Note the large amount of mudstones in the Pine Island Shale. We assume that the lack of biota in carbonate sediment and the lack of carbonate sediment are associated with the pre-OAE1 stressing the environment. The factory shut down, or the section here was overwhelmed by influx of siliciclastic sediment. Here are some Pine Island thin sections. first let me mention these two here are cross nickels and they're rotated to 45 degrees to show the alignment of the clay minerals. So the upper left here is the silty argillaceous mudstone. And you can see by the bright birefringed color, it shows the clay minerals are all lined up, which tells you essentially there's a lack of total bioturbation. There may be a few burls here or there. This might be one right here filled by silt. The bottom left here shows a very silty and sandy argillaceous mudstone. And through here, there's some sand-sized material, a lot of silt material in through here. So it's a mix. In here, these are pretty much dominated, these two thin sections are dominated by schistoclastics. Center thin section shows silt-filled burls in a mudstone. And this again is under cross-polarized light, but here are the little burls, look like could be chondrites in through here. Again, looks like deeper water sedimentation. In the upper right here is a fragmented oyster fragment and a couple oyster fragments in here. And down here in this thin section is an echinoid plate, little oyster fragment, and a lot of quartz silt. Moving up into the lower Cow Creek, this was deposited during a regressive half of a composite sequence. Here's a composite sequence. We're going into the regressive part. It captures most of the OAE1 proper. Here's an OAE1 proper right through here. This increase in delta C13. And what's interesting here, often I've heard the OAE1 was associated with the Pine Island, but actually most of the OAE1 is in the lower Cow Creek. It starts in the Pine Island, but goes into the OAE1 here. The carbonate factory was actually shut down during most of the pre-OAE1 and started up again during the OAE1 proper. Here's the lower Cow Creek on a wireline log. And as I said, the OAE1, pre-OAE1 started through here. Then, the OAE started through here, moved up into the Cow Creek. Most of it's in the lower Cow Creek. The section became carbonate rich again as a somewhat repressed carbonate factory is reestablished. So coming out of mostly the terrigenous type mud rocks, we're now to some larger bodies dominated by oysters going up into wacky stones and pack stones. Lower Cow Creek also in East Texas would be called the Lower James, was deposited on the flooded low energy middle ramp. Oysters dominated the fauna, and there are no benthic forams or green algae as is noted in the Sligo. So the biota is still somewhat suppressed. I interpreted much of the lower Cow Creek deposition as having been influenced by storm processes. The top of the lower Cow Creek is considered to be a third order sequence boundary up here. One second. Okay. Both these core slabs are rich in oyster fragments. You can see all these dark grains. They're fragmented, and each have mud clasts. Okay, here are the mud clasts. You can see here's a group of oyster fragments, but they're in these blobs of mud. Here, shown here, 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 especially something like this here. And I think these are actually clasts of oysters that were in mudstone, got ripped up and transported as a debrite. And I think the same is happening over here. And what happened, these could be ripped up by storms, and then a storm return current creates a gravity flow, moving them down dip. Therefore, transport by storms and associated storm flows were important during the lower Cow Creek. On the left is a burrowed mudstone. Whoops, that's the next slide here. Yeah, on the left is a burrowed mudstone with argillaceous clay wisps. These Mudstones are common at the base of high-frequency cycles, including deeper and lower, indicating deeper and lower energy conditions. The core slab second from the right, this one right here, is a carbonate grainstone, suggesting a carbonate sand flat. It's fairly well sorted, and it pretty much lacks any mud. And there you can see these white circular things here are worm tubes that probably were commonly attached to the oysters. The far right core slab shows the contact between the lower Cow Creek here and the upper Cow Creek above. And the upper Cow Creek base here is a terrigenous mudstone. This is a third order sequence boundary. And I want to suggest that this thin pressure solution seam zone may be a product of subaerial exposure or weathering, the way it is looking like a solution class in here and whatnot. It may be a weathering zone, but it fit to a third order sequence. These are examples of lower Cow Creek thin sections. Over here on the upper left show fragments of bivalves and a gastropod and a grainstone through here. It is the whole thin section. The lower left thin section shows the only benthic foram noted in the lower Cow Creek. I'm showing this to keep honest that I do see extremely rare benthic forams, but they don't come in again into the lower Odessa. The other thin section displays common elecons, including oysters, bivalves, and oyster fragments. Again, many appearing transported. The lower right thin section also contains abundant quartz. But even look at this oyster fragment here. Notice the attachment of mud to it. So this could be some sort of interclass. And one last core slab from the lower Cow Creek. This is from up here. This is a big fault zone in the well. I think it's a normal fault because you see this lithofacies here, you can see up section. This lithofacies here, you see down section, which indicate a normal fault movement. And in the fault zone, you got coarse crystalline calcite precipitated, and you do have some bugs left. Again, creating possibly a porous, not a porous, but a permeable fault zone. So I'll stop here and then carry on with the upper Cow Creek in the next set of slides.